Hello, everyone. My name is Carmen, and I'm from the IDERA marketing team. I'm going to give it one more minute for some more attendees to join us. Okay, so hello again, everyone. Thank you for joining us for this webinar on how to harden SQL Server security. Again, my name is Carmen. I'm from the IDERA marketing team. During the presentation, everyone will be muted to avoid background noise and disruptions. If you have any questions, please add them to the question field in the webinar panel. We'll leave some time at the end of the presentation for questions and answers. This will be a 60-minute presentation, first with Brian Kelley and then Ray from IDERA. Brian Kelley is an author, columnist, certified information systems auditor, certified data privacy solutions engineer, and accredited CISA trainer, and former Microsoft Data Platform SQL Server MVP from 2009 to 2016, focusing on SQL Server and Windows security. He now serves as a technical architect covering data, infrastructure, and security, concentrating on Active Directory, SQL Server, and Windows Server. Brian has a myriad of other positions, including senior database administrator, data warehouse architect, web developer, incident response team lead, and project manager. And following Brian's presentation, Ray Rios will give a 50-minute presentation on our SQL security tool. Without further ado, I hand it over to Brian to get us started.
All right, hello everyone. Thank you for taking time out of your schedule to attend the talk today. So I'm going to cover basics on how to harden SQL Server. I'm going to try to do it by talking about a particular security incident that kind of caught the world by storm a couple of months ago, and that's DB Jammer, and then kind of pulling lessons out of that we can apply and where I think they made some mistakes and how to avoid that in your environment. It's not comprehensive. There are a whole day pre-cons on SQL Server security. There's plenty of articles out there. So let's go ahead and get into it. So you heard a little bit about me. Basically, this is just a recap of what Carmen already shared with you, so nothing new here. If you need to get in contact with me afterward, my email address is right there, kbriankelly@acm.org. Notice it's an EY. And I am still technically on Twitter X with kbriankelly, but I'm not very active there. I do write periodically again, and those are the two blogs. The first one is focused primarily on infrastructure security. The second one is focused on things like use of time and that sort of stuff. So enough about me. Let's talk about the agenda. So we're going to do the DB Jammer walkthrough, and I'm going to put a few demos in to kind of show you where I think things went wrong, at least on the SQL Server side. If you're primarily a DBA and you don't have your fingers in the networking or the server side, this is where you'll need to reach out to those teams with the large good organization and make sure they're doing the right things as well. Because the reality is that it's a blended or what we call layered approach to security. The hardening side, we'll talk about the low-hanging fruit, things that you can do right away, and where to go next is probably your next steps. As always, carefully evaluate any kind of recommendations for your environment, understand the impact before you go in and apply them. There's a reason why in the industry we've started to move from the use of the term best practices to good practices, because a best practice may not be best for your organization. All right, so how the attackers got in and why. That's really what we're interested about in DB Jammer, especially from the SQL Server side, right? SQL Server was just a method of exploit and the method of penetrating into the internal network. So the first problem, and it's it's a common one is that SQL servers were on the internet. Now, I'm going to ask a specific question about this a little bit later, but for whatever reason, the SQL servers were on the internet. And this has always been a problem. It goes back to, if you know the SQL Slammer, if you were in the industry back then, right, those were SQL servers that were exposed to the internet. There was an exploit that was published by Mark Litchfield. It was actually patched, but people didn't apply the patch in a timely manner. And as a result, it was basically an in-memory worm that allowed for continued exploit. It actually caused degradation of the internet, especially around Korea, when SQL Slammer first kicked off. And that caused Microsoft to actually reevaluate their entire practice with regards to building software. And at the time, they coined something called the Trustworthy Computing Initiative. And it all started because of SQL servers on the internet. Well, DB Jammer, you had SQL servers that were on the internet, and those SQL servers were exploited. They weren't exploited because the SQL servers weren't patched or anything like that, although that is still a proper practice, and I will say that's still a best practice, is to keep things patched. So let's talk about SQL servers that were on the internet. So in most cases, when we look at a network architecture, SQL servers are not accessible from the internet. This is what is often referred to as a castle and moat network architecture, right? Where you're just simply blocked. The SQL servers are accessible internally, and this is what you would see in most traditional organizations. If you're on the internal network, you have access to the SQL server. If you're not on the internal network, you don't have access. Some people have often referred to this as also the M&M approach, because you have a hard outer shell and a soft inside, but you get the idea. And our network architectures are evolving. So this is what I would have expected. I would not have expected a SQL server to be directly exposed. Now, there are definitely use cases for that, and there are ways to protect around that. As I said, it wasn't just the fact that the SQL servers were on, but let me say this, it wasn't just the fact that the SQL servers were on the internet that the attackers got in. That was one of a series of miscalculations and misconfigurations that allowed those SQL servers and ultimately their environment to be compromised. So just there may be a valid use case for a SQL server to be on the internet, but make sure you take the appropriate layered protective actions to do so. So if we have this traditional castle and moat and you do have external users, we do have cases where users need to come in, but usually we see technologies like VPN, right? They authenticate, create a VPN tunnel, and then they're treated as part of the trusted network. And so as a result, folks that need to get access like this can do so. Now, if you have SQL servers and that sort of thing in a cloud service provider and not on-prem, most cloud service providers have some sort of private VPN mechanism that can be set up. Microsoft certainly does, AWS does, you get the idea. So VPN is always an option, and most of your network appliances that are firewalls or your Bastion host, load balancer, those types of things, they also provide some sort of VPN solution nowadays. Once upon a time, a VPN concentrator was a separate piece of physical gear that you installed in your data centers and people connected to. Nowadays, it's usually built into the firewalls and stuff like that. So chances are that if your organization has a professional grade firewall of any major vendor, you already have the VPN and you may even be using it. But in any case, this is the way I typically see SQL servers being accessed if someone from the outside needs to access a SQL server on the inside. Now, like I said, there are still valid cases where you might put SQL Server on the edge. I'm not sure because the details as far as what they were being used for wasn't covered in the DB Jammer write-ups, nor would we expect them to be. But if they don't need to be on the internet, don't put them there. Now, the industry is moving to something called the Zero Trust Network. So here's an example from Azure where effectively you're on the internet, you come in to an edge virtual network, and you're going to go through a firewall if you're talking to a SQL server of some sort, if you're talking IaaS or a SQL virtual network. There's authentication all along the way. In addition, there's something we call network security groups that are in place that carefully control what traffic goes where. So part of the Zero Trust, and we'll get to the principles in a minute, is to ensure that you know explicitly who's coming in and you're designating traffic and so on and so forth. And there's policies and all that stuff to set up. Most of the cloud service providers can do this. Modern networking, as it's transitioning, is doing this. You might also hear the term software-defined networking. But in other words, you should be seeing architectures move this way as far as networking is concerned, as far as SQL servers are concerned. Now, you may say, well, what if I need to remote into a particular system because I have SQL Server installed on a Windows server running in a cloud service provider? I'm using Azure because that's what I'm most familiar with. In that case, Microsoft has something called an Azure Bastion, which allows for RDP access. You're authenticating against the Bastion, and the Bastion is serving as something that we usually call a jump host to get to the backend Windows server or Linux server or what have you, right? So these are the traditional architectures I would have expected to see. I would not have expected to have seen a SQL Server exposed internet. Like I said, there are use cases where you do that, but generally speaking, it's not a common one. You do it if you have a specific justified business reason that overrides the risk of putting them on the internet. That's probably the best way to say that. So with regard to zero trust, there's three basic principles that anyone who adopts zero trust basically adopts these principles. You might see someone say they have 5 or they have 6, but you'll always see these 3 embedded. The first one is that you verify explicitly. Think back to the VPN slide, right? In order to create the VPN tunnel, you've got to authenticate. Chances are you also have to have a VPN client, and some organizations even have a point where your VPN client passes, say, a certificate or something like that. So the client, the device is being authenticated, the person is being authenticated, and on the back end, the VPN could be set up to where you can only go to certain regions of the internal network based on your job role or whatever, right? Well, all that has been in VPN for a long time, so it's no surprise that it's in zero trust. You want to verify explicitly. You want to control the traffic. You can't just not just everybody gets access everywhere, right? Usually it's well defined. This set of folks has access to this. And technically speaking, from a SQL Server perspective, things of that sort can be done, or anything put on the internet could possibly be done. There are ways to do it depending on where your users are, but from a zero trust perspective, as more and more networks move this way, you're going to see that verify explicit. The next one is to use least privilege access. This is just an industry security principle, right? Always use least privilege access. The problem isn't necessarily that the person is untrustworthy. The problem is that the person's account could be compromised, the person's device could be compromised, and the person who compromised the account or the device is definitely untrustworthy by simply a matter of them going and compromising someone's account. So the example I give on the security side is that you have a secretary who's lived there, who's been at the organization for years and years and years. Everyone loves her. She's fully trustworthy, and she has more access than they should because she would never do anything wrong. But then she clicks a link for a phishing email. Her computer gets compromised, and now they're running under her credentials. And the additional access she shouldn't have are now being exploited by someone who is looking to do damage. Whether it's to exfiltrate data or expel data out, or do something to your organization, right? The other thing about zero trust is that you assume a breach. You assume that you're already compromised in some way, and so as a result, you're segmenting your network, you're restricting access, you're only granting explicit access between resources, so on and so forth. The software-defined networking, that becomes a whole lot easier on premises. Obviously, the cloud providers have support for that. If you know anything about network security groups in Azure, that's the whole point behind NSGs, right? Is to restrict it. If you start with the assumption that you're compromised, then what you're trying to do is minimize the impact, minimize the damage. And so from a SQL Server perspective, that's one of the things that they should have done with regards to the SQL servers that were exposed to the internet. Those should have been compartmentalized somehow in the network, but they weren't. And so let's talk about the SQL Server side itself. Well, the SQL servers were exposed on the internet. And so the attackers went, you know what, let's try to log in. And we'll keep trying to log in until we get the right password. Now, if you're able to log in this way, that implies that there are weak passwords in play, right? Because if I have sufficiently long passwords of sufficient complexity, I don't have enough compute power in order to brute force in any reasonable amount of time. So the fact that I can get in means that the passwords are weak. Now, let me say that by weak, I don't necessarily mean that the passwords weren't complex enough. It could be that passwords were reused and those passwords appeared in a dump somewhere and someone grabbed them and tried them. Now, we don't know what accounts exactly were used, but we know that they obviously were not subjected to password policy enforcement. Now, with SQL Server, you can't actually set the password policy. So I can't set the number of characters. I can't set how many times a login failure happens before lockout occurs or anything like that. I can't set it at the SQL Server level. What I can do is tell SQL Server to look at the OS level and then use whatever the OS has for setting, which makes perfect sense. And if your organization is properly using Active Directory and GPOs, then those settings should be being pushed out
as part of the domain policy, in which case they should meet any and all audit requirements. The fact that these systems were able to be brute forced, or logins were able to be brute forced, implies one of two things. Either the password policy enforcement wasn't there at the login level, or you had a weak password policy. I'm going to bet it was probably that the logins were created without a password policy enforcement, and we'll see why when we get to the demo. The other thing that the brute forcing causes us to think about is that either failed login events weren't being tracked, or they were being tracked and no one reviewed them, or obviously if you don't have logs at all, no one's reviewing them. So it could be a matter of there was nothing set up like that. Because if I have failed login events and I have a number of them and I have a sudden increase in failed login attempts and someone's reviewing the logs, then the brute force should have been caught. There's a saying from the audit world, which is, if no one is reviewing the logs, then you do not have a control. So it's either the failed login setting wasn't turned on, or the extended event wasn't configured. There's a recommendation in the CIS benchmarks to instead use extended events to capture it. And if you email me, I'll point you to that. Or it was turned on, but no one was looking, right? So let's look at some login examples. So I'm going to flip over to SQL Server Management Studio. Now, I've already run this first script, but I wanted to show it here. Notice that I can create a login, and when I create the login, I have the setting check policy equals off. So this tells SQL Server, create a SQL Server login, assign it this password. I chose weak password just to make a point, and don't evaluate the policy at all. Okay. This one, I'm checking the policy, but I'm setting the expiration off. Now, if you are familiar with the National Institute of Science and Technology here in the United States, which is a federal government entity, NIST published a new special publication. I think it was SP 800-53B. In any case, the new recommendation is don't rotate passwords unless you have evidence of a compromise, because the research behind that recommendation is when you force people to rotate passwords, they tend to choose weaker passwords. So it's best to let them choose strong passwords, because they will natively if they don't have to rotate it, and then only rotate when, like I said, in an example of a compromise. So, and as a result, organizations like the Center for Internet Security for Microsoft and others have changed their recommendations to where they still do the account lock, they still do the password complexity, the password length, remember the history of the passwords, but password rotation, in other words, password expiration, is no longer a recommendation, at least at the OS level. So keep that in mind. And then I've done a login that has both turned on. So full password policy, it's going to check the policy, and it's also going to check expiration if that's been set, right? Because I'm going to query some things on least privilege later, I've also done some roles and granted some access, and granted role membership to a couple of the logins. So that's fairly straightforward. That's already been run. So let's go and check what's disabled, right? So when I go to look at a SQL Server and I'm auditing, I want to know what's disabled and what's not. And one of the things that I want to know that's disabled is this login right here, something else. Notice though that the SID is 0x01. 0x01 is always the SA account. Their best recommendation is you rename that account and you disable it so that it cannot be logged into. I wonder if that was actually done in this particular case. It could be that a person's account was compromised, especially if they reused the password. But in any case, I want to ensure that this is definitely disabled and that when I see 0x01, I don't see SA. Okay. I also want to check to see what policy or what logins do not have policy enforcement set. So notice that is policy check equals 0. This says this is false. When I run this one, I'm going to get one right here, the one I told you that I created. Now these here, what I've done is I've just created logins for the ownership of the databases. These are disabled on purpose. There to prevent the databases to be owned by sysadmin. So if cross-database ownership chain is turned on, you can't get there from here. If you have questions about that, email me. I'll be more than happy to do it because that's beyond the context of this presentation. The other thing I want to do is I want to just see which ones have the policy enforced, but expiration turned off, right? And of course, the full password policy is that way. This login that I've created for the demo is that way. But notice that the SA account, of course, is not. That's not a surprise. So those are some of the checks that I run normally, right? When it comes to checking the logins. Now, the other thing that was interesting was reading the write-up. The attackers used XP command shell. So they were able to log into the SQL Server once they brute forced the password, get into the account, and then in order to do the next set of operations, which was to try to get stuff onto the OS and then be able to start laterally moving, they used our all-time favorite XP command shell. So let me talk about XP command shell for a second. One thing is that in the security recommendations for like the CIS benchmark, we don't actually recommend disabling the XP command shell anymore because it becomes a question of what's the point, right? XP command shell is an extended store procedure that's in a DLL that you can't get rid of. So that means the sysadmin level can re-enable it. Here's the other thing. Unless you have configured it differently, only sysadmins can execute XP command shell. So there may be an argument to disable it and then have audit checks to see whether or not XP command shell gets re-enabled and by whom. You may be able to make that argument, but you could also just audit for the use of XP command shell in various ways. So the point I'm making is that since sysadmins really can re-enable them and you can't stop them, and since by default only sysadmins should have access to XP command shell, there isn't a good recommendation nowadays to disable it unless you just want to be as tight as possible. But realize that it gives a false sense of security because, like I said, a sysadmin level can re-enable it. All right, so with that said, if attackers were executing XP command shell, it implies that the compromised logins were at the sysadmin level. So disabling wouldn't have stopped their use, they would have simply re-enabled it, so on and so forth. Probably it was a well-known login, and the most well-known login, of course, is SA, which is why the recommendation is to disable it and rename it, right? So that's something to look for. Now, we can check for XP command shell. That's fairly easy to do. As a matter of fact, I'm going to pop back over to Management Studio and notice that I'm going to run spconfigure. I'm going to show advanced options because that's how I can get XP command shell. When you run it, you set it to 1. Just tell SQL Server, hey, don't just show me the small set, show me the whole set. And in order for it to take effect in this session, you run reconfigure override. I'm going to do that. And I had already run it, but you always do that just to be safe because it could be set to 0. It doesn't impact your performance or anything like that, so there's no issue with that. And I notice I'm specifying spconfigure with XP command shell, but I'm not setting a parameter. So what I'm telling SQL Server is just tell me what the values are. I'm not interested in setting it. Now I could run spconfigure without specifying XP command shell, and then I'll get the full list dumped. But because I just only care about this one setting, I'm explicitly setting it. Now minimum, maximum makes sense, config value. So 1 would mean it's turned on, 0 means it's turned off, and in my case, it's turned off, which is what I would expect. I have not intentionally re-enabled it, so it is what it is. But that's likely what happened. So attackers did recon and created logins at OS level. Oh, before I do that demo, before I go to that, let's talk about the permissions. So I mentioned that if in order to execute XP command shell, they likely had sysadmin level access. So we do want to always check roles, and you want to make sure, if by principle of least privilege, that logins assigned to roles are only assigned to roles they absolutely need. So this is a simple query. There's plenty of articles on the internet about how to put these security catalog views together. You can check the Microsoft documentation online for it as well. But basically, I'm going to use server role members. This is effectively a join table for those that are very familiar with those. And the roles and the users are actually in one effective table set for us, and that's called server principals. So in this case, the P represents people, or principals, R represents roles. And so I'm getting back what are the roles that have members and who are those members, right? Because I'm using inner joins. So if I run this, I'm going to see the following. I'm going to see that no password expiration is set to DB creator, full password policy is set to security admin, and then I've got all of these that are sysadmin level. That's the renamed SA account we know. That's the one I'm using currently. The rest of these are service accounts. We expect that. And then I have built-in administrators listed because this is a demo box. But in general, a lot of cases, the recommendation is to remove built-in administrators. I always put it in the demos in order to call it out specifically, because generally speaking, if you're talking about a principal of least privilege, most of the time your Windows OS admins do not need access to your SQL Server, even if it's installed on a SQL Server. And yes, there are ways of gaining access if you're a Windows admin to get to the SQL Server, but it requires you to take additional steps that not everyone knows how to do. And so as a result, the recommendation in the industry is to remove built-in administrators. And if you have DBA groups and stuff, use those explicitly. Don't just make DBAs a member of administrators at the OS level and add them. Create the group in Active Directory, add them directly into SQL Server. That's a general recommendation, and built-in administrators should therefore be removed. But like I said, because of the fact I want to call it out, I always include it in the demo. Now, roles don't tell the whole story. So there's a lot of documentation on what Microsoft calls securables. Securables are basically anything you can assign permissions to. They debuted in SQL Server 2005, and there are a lot of them. One that we care about in particular is something called control server. So I'm going to intentionally filter out the connect ones, right? I just want to see the ones that are not related to connect. And I see a bunch, I've sorted them, but I see this one here, and this one is of concern to me, right? So user with control at server level is actually a role. Control server is the equivalent of sysadmin access. So I would want to know why that exists and make sure that it's justified. Because if I'm an adversary and I'm trying to ensure that I have persistent administrative access, I'm not going to add my accounts to sysadmin role. I'm going to create a user-defined server level role, and I'm going to grant it the right permissions, or I'm going to create a login, and then I'm going to grant the login explicitly to control server permissions. So you want to look at both roles and permissions, at least at the server level, from a low-hanging fruit perspective. All right, so I've executed XP command shell. Now what am I going to do with it? This is where we step beyond what is traditionally a DBA world, but in order to understand the impact of the lack of proper security on the SQL Server, we need to cover what was done by the attackers. So the first thing they did is they did an enumeration of the system. Basically, what Windows version it was, key directories, key users, so on and so forth. They also were able to capture what domain it was, what the name of the server was. Oh, and by the way, the user account for the shell process, what was the user? And then from the write-up, they were able to create new users. The permissions that are default for SQL Server service accounts do not allow for the creation of new users. This means that another best practice recommendation on the security side was violated. And I can say best practice because remember, the principle of least privilege is what should be in effect. The ability to create new users and then grant them access to remote desktop means they had privileged access, or the SQL Server service account had privileged access on that server. Likely, they took a shortcut and just dropped it in the administrators group. SQL Server doesn't need this, and if you are installing SQL Server for, by the GUI, by the command line, or you're going in and changing the service account using SQL Server's configuration manager, those two mechanisms will ensure the least privileged set of permissions is set for SQL Server. The only reason SQL Server would have more is if it was added outside of the SQL Server installation or configuration processes. For instance, hey, I'm going to run SQL Server in a service account. Can you go ahead and make it as an admin on the box? I'm going to log in as that service account, and I'm going to install SQL Server using that service account. That's a practice that I've seen a lot. It needs to go away in our industry, right? DBA should have the ability to install the SQL servers. Better yet, you should be able to have processes do command line installs so that there's consistency, so on and so forth. But the fact that they could create accounts and then manage groups on the local OS meant that SQL Server had way too many permissions. So what permissions should it have had? Well, if you check the documentation, here's the list. Now, by the way, none of these are tied to a particular group. In other words, I grant you a group, you automatically get this access. There is something called local security policy or local GPO. These are permission sets that are within them. Certain groups are by default have access to it, but your configuration, your installation process for SQL Server will go in as long as it has the appropriate rights at the OS level and make sure your SQL Server service account, whether it's a virtual service account, whether it's a local account that got created, whether it's a domain user account, whether it's a managed service account created in AD, or if you are doing something like AGs and Kerberos and things like that, and you have a group managed service account, whatever it is, SQL Server, the installation, right, and the configuration manager will ensure the service account has these permissions. You don't need to set any permissions at the OS level. You definitely don't need to make SQL Server Service Account the administrator. And then that's it. This is done. You don't actually have to remember this list because, like I said, the tools do it all for you. So they brute force the login. They get into the SQL Server. They realize they can use XP command shell. They use XP command shell to basically recon the server. They create the local user and assign it to groups, remote desktop users, so they can RDP in, hopefully, but also so they maintain persistence. So even if so now that I've created the local user, if I can get to the OS, I never have to use SQL Server again. I can just bypass it and just go straight in. So this is how they went on the offensive. They immediately then started looking for things like network shares and other systems that could compromise. And they found out where they could get footholds. And then they downloaded ransomware. And then they put ransomware in. And it all started, and they interrogated the registry because these servers, in fact, were accessible on the internet via remote desktop protocol, RDP. They just weren't potentially listening on the standard port for it, which is 3389. Now, the reason I don't have bullets for this is because at this point, we've crossed over from DBA land into usually server administration and security incident response. But the fact of the matter is that through the use of XP command shell, they were able to create the logins in the groups they needed. They were able to download their malware. They were able to interrogate the environment, go further, which goes back to that assumed breach mentality wasn't done, right? So I'm in, I have access to everything. I'm in the traditional castle and moat network architecture because I'm in an internal network, I'm trusted. So I can go anywhere. I've got my malware in. I know where to put stuff. I start executing the malware. It starts spreading. Eureka. And henceforth, we have DB Jammer. So hopefully that all makes sense. If any of that was confusing, please feel free to ask a clarifying question or email afterwards if it hits you. So let's talk about hardening low-hanging fruit, right? We've gone through DB Jammer. There's a lot of information that we just unpacked. So what are some of the bullets that you can take home, especially if you're new to the process? Well, first, I'm going to ask you the simple question on that a little bit later. Does your SQL Server need to be exposed? If you do not have a solid business justification where the business value outweighs the business risk, your SQL Server should not be exposed. Now, if business value outweighs business risk, expose SQL Server, take appropriate countermeasures that you can, period. Does RDP need to be exposed? That's a really big one for me, right? And this isn't the first time we've seen that. There was a particular credit bureau a number of years back that had domain controllers exposed to the internet by RDP. So even the best of the best of the best can mess this up. Don't expose servers by RDP unless that same rule applies. There is an overwhelming business value that outweighs the business risk, right? And then I'm going to ask the question again, seriously, does your SQL Server need to be exposed? Because the vast majority of the times, there is no actual business driver for exposing the SQL Server that outweighs the risk of putting the SQL Server on the internet. From a network layer, ask those questions, and, determine whether or not your business really needs it. The vast majority of the time, the answer is no. The OS level, of course, always patch and verify patching. In this particular case, they did not exploit a vulnerability due to patching. However, I can tell you that reading a lot of the defense forensics incident response, what we call DFIR reports, for a lot of exploits. I can't tell you how many times that I read a report and it's because the system hadn't been patched. I read a report about a month ago where attackers got into an enterprise environment because some of the software being run on the exposed web servers hadn't been patched and the patch had been available for over a year. That's not a good state to be in, right? That was something they definitely could have done something about, but they didn't, and as a result, they had bigger problems than applying a patch. At the OS layer, audit for login and group changes. There are settings at the Windows OS that you can definitely make. Obviously, someone needs to be reviewing those. Those audit events go into the Windows security event log, and something should be extracting those and reporting on them. A lot of organizations now have some sort of SIEM, a security incident and event management product. You hear terms like Splunk and Logarithm and others that are out there. those should all be extracted, especially on servers exposed to the internet. One of the things that they did do to try to make sure that they could get back in is they disabled the firewall. Obviously, once they got access to remote desktop, they could do a lot of things, but they disabled the firewall. They actually ran a netsh command to disable the firewall. You can enforce the firewall settings using group policy, and that should be set that way for your organization. That way it's consistent, so on and so forth. At least making sure that they stay on and stuff. Also, not only did they disable the firewall, they disabled any of the defensive mechanisms that are in place. Antivirus, Defender. Defender was specifically mentioned. They disabled Windows Defender. And so as a result, those things could never fire. Or they didn't disable the Windows Defender. They disabled the prompt for submitting. So if Windows Defender detects something that says, hey, this looks suspicious, can I submit it? They disabled the prompting of the user. They just said, go ahead and submit it, right? So the user would never know that something suspicious was running. It just would get sent to Microsoft, and so as a result, they went and did all those kinds of things that they could in order to make sure that the defensive software didn't trigger. The recommendation here is obviously set those kinds of things up to where they're being detected, right? And there are various mechanisms to do that, but that's what should be done at the OS layer. Now, from a SQL Server perspective, what we can do is we can audit the policy enforcement. Are there any SQL Server logins that are not enforcing policy? If they're not enforcing policy, then they can have weak passwords, and we don't want that. Now, there are always exceptions. Some vendor has hard-coded a username and password, which is bad practice. Don't do it, into their application, and you're stuck with it, and it's not going to pass your complexity requirements. Especially older software, I've seen that more times than I want to count. But we should know what those logins are, and we should definitely audit for them. Audit the permission levels within SQL Server. I gave you a couple of quick scripts. Obviously, follow the principle of least privilege. Definitely, as the first thing you do whenever you install a new SQL Server, have a script that disables and renames the SA. It's okay to make that name consistent throughout the organization. As long as the account is disabled, actually, it might be beneficial because at that point you can see it. There's pros and cons for having a consistent name across or having something that's more dynamically generated. But the bottom line is SA should be renamed and it should be disabled. Also, make sure your SQL Server service is running with least privilege. There is no reason to add the SQL Server service account to the administrators group. Don't do it, right? Let SQL Server's tools set the permissions and you'll be fine. So beyond the low-hanging fruit, what's next? Well, obviously, most of these require collaboration with other teams, but really protecting SQL Server is, like I said, a layered approach, right? That's why I mentioned network, OS, and SQL Server itself. I could put onto it security monitoring and everything else, but you get the idea. So if your organization has the capacity to do so, start moving to zero trust networking. If you're in a cloud service provider, Azure by default is zero trust, and you have to effectively bypass it by putting settings in. Utilize what your tools already provide for you. Network microsegmentation is a must. You can do that even without zero trust, right? If only certain systems should be able to connect to the SQL Server, make sure only those should connect. If the SQL Server should only be able to outbound connect to certain things like domain controllers and DNS, and possibly other systems that are related, such as antivirus and other security measures, because a lot of those fell at home, then make sure that your SQL servers can only do that. Because if the SQL servers had been blocked where they could not talk to the rest of the network, then the ability for the attacker to exploit the compromised Windows OS that the SQL server is running on would have been much, much limited as far as what the impact could be. Proactive alerting on suspicious activity. There's a number of mechanisms for doing this. There are tools in place that run on the OS that can say, hey, I'm seeing Command XC. Command XC, there are use cases where those get run properly, but if a SQL Server process is running Command XC, that's really suspicious. Audit for login creation, both at the OS level and at the SQL Server level, right? It creates an audit trail. So from an auditor's perspective, I put on my auditor's hat. What I want to see you do is if you have a login creation, I want to see a change record that goes along with it in some way, right? However your change mechanism is. Pulling the report allows you to true that up and determine that there are logins that were created without change records and stuff like that, and then retroactively put the documentation in so that when I come in as an auditor, I don't hammer you for that because of the fact that you have report control. Configuration changes, definitely. Audit for those. There are tons of scripts that can be run. There's tools that can be used, but you're trying to detect unexpected change, undocumented change. It could be that there is not a security incident. It could just be that a junior admin at some level misconfigured something and without realizing that they shouldn't have been touching that. Verify least privileged database level. I gave script for checking permissions at the server level. You can write this, that you can find those scripts at the database level. Verify that the permissions are what they need to be for the application run, for the users to have access, and also periodically review for old accounts. It could be that a login was not disabled and someone reused it. So if you are familiar with something called the Colonial Pipeline hack, which was a big ransomware hack, the adversaries were able to get in because they were able to use the VPN tunnel, and they used the credentials of someone who had left the organization whose password happened to be reused. So if the accounts had been properly disabled, then the Colonial Pipeline ransomware attack would never have happened. All right. So I know I threw a lot at you today. Obviously, ask questions in the chat area and email me afterwards if you have any more. But we talked about the DB Jammer. We walked through it, and we talked about what low-hanging fruit you can take as your next steps, and then where to go to next beyond that. So with that, I think it is time for Ray.
Yep, perfect. And I'm going to show my screen right now. Let me know if you can hear me and you can see my screen, please.
We can, right? We can.
Perfect. Thank you so much. Okay, thank you, Brian. Okay, so what I'm going to talk about, I'm going to spend about 10 minutes here on two of the products that we have for security, the security suite products. And that's going to be the SQL Secure and the SQL Compliance Manager. The SQL Secure, which is the first one that we're going to see here, is a tool that allows you to see your security model in your SQL Server and allows you to, based on policies that you either create or you get from the product, allow you to do a lot of different checks for security. And then basically you can see whether you pass or not on those SQL servers. And then it allows you to enforce those later on somewhere else, maybe using Management Studio or any other tool that you might want to use to do that. So the first thing that we do here is only to understand your security model. So what we're going to do is we're going to take a snapshot of that SQL server, and then we will be able to see everything based on what you told it that it would either pass, would be a high risk, low risk, or some informational findings that it has here. So the first thing that you do, you take a snapshot. I'm not going to do it right now. You take a snapshot. It runs for a couple of minutes, and it brings all of this information. Now, before you do that snapshot, the one thing that you want to do is you want to take a look at the settings for that, right? So in order to do that, you first need to create a security check, right? And then for that, you create a profile. And that profile, that basically the rules that you're creating here are basically going to give you all of the different things that you can check with our product, right? And you can define, first of all, you can enable or disable what you want to do within that policy that you want to do. And then you can define exactly what that check is basically you're going to be doing. So for example, in this check that is always encrypted, we have it enable, then it tells you what it is. External cross-reference, that is if you use anything from any regulations that might be from security, like DISA or CIS or anything like that, that you might be using. So it's going to external reference that to that document, and it will put that automatically here. Or you can do that yourself too. Then you can name that risk for you. What is it? High, medium, low. It already comes pre-populated with some of those risk levels, but you can do that. And then some of the times on those, so you can select a criteria, where there's going to be an object, where there's going to be a criteria for a database that you want to include into that security check. Then you can put that criteria here. So there's a lot of different things that you can change here, right? And then you can change that specific criteria that you're looking for in that check. Okay, so you can see the criteria here, like Brian was talking about XP command shell. I mean, that's one of the ones that we have here, right? And like you said, you know, it might not be something that necessarily it is recommended to do a check. You can put it here, you can edit it, you can remove it if you don't want to do it anymore. And like he said earlier, he said earlier that we can do maybe an audit check on that. So we're going to talk later about the product that's Compliance Manager that might help you with some of those checks for auditing, right? But this is only to understand your model, your recovery model here. I mean, your security model, okay? So once you do that, then you can run that, take that snapshot, and you can do that manually, or you can do it on a schedule. So you can say, I want to do it every day, every week, however you want to do it, and then it will bring you something like this, right? So once you run that check, you have all these categories that you can take a look at, or you can see all of them, and then see everything that's, first of all, is going to give you everything that's a high risk, right? And on the bottom, you're going to have what are the findings, right? So it's going to tell you, for example, here, the backup encryption is going to say something like on Taylor, which is the only one that I have here, the instance, these are the following databases that do not comply with that. So it has a vulnerability, right, on those, right? So if we go to SQL job permissions, so again, it would tell you here the details on that, right, on the job permissions. The level is a high level. Why? And it's telling you here, and it's giving you the findings. Which ones are the users, right? They have the administrator role that maybe are something that are not supposed to happen. So it's giving you all of those. And then again, if you name something at a level that it might be a warning or a medium risk or just informational, right? In this case, it might tell you CLR is enabled. So just an information thing, maybe it's a low risk, but you still want to have that showed up here. And then you can see it based on the categories, right? So if I want to see logging categories, auditing, and anything like that, then I can take a look at that, those things, right? So that's one way of looking at everything here. So if I do, again, take a snapshot, I would take it from that user, and then it would collect the data. I can hide it, but it's doing that collection for everything else that we have here, okay? So that is one way of doing this. The other thing that you do here that it might be important is that you can compare assessments. And then you can compare, let's say if I did something today, I took a snapshot today, I want to compare it to a previous month. And then I can see the difference between those two, right? And in this case, I don't have a lot of differences on those because there's not a lot of changes on my laptop here, but you can see some of the differences that you have here from one to the other one, right? So you can do a comparison of whether you're actually getting better or worse, right? In this case, it's about the same. I think there's only one change here on the blue one, which is going to be your informational or low risk. But you can tell here basically how you are basically doing between those two, right? So you can compare those different checks that you're doing on those two different servers. So that helps you to understand if you're progressing with your security model or not, enforcing those rules. The other thing that you can do later on then is either, well, you can save an assessment, but you can also publish a security model, and then you can publish also a baseline. That means that that is a baseline that you're going to be using for future servers that you're going to be applying or checking for this security model that you have with SQL Secure. Okay. So in essence, that is one of the main things that you can do with this product. The other one is to explore the permissions. And to explore the permissions for the user, you can click here on at the instance level. And once I do one of those snapshots again, or I can take it here if I want to, then I can start looking at a user permission, And if I go here, I'm going to use, I think I have this one right here, this user, and I can look at the server or the server in a specific database, right? So if I go there and I choose financial records, I can do show me the permissions for that user. So it will show me the permissions that I have assigned. Okay, and you can see here the server level on all the different permissions that I have assigned for that user, as well as I can see the effective permissions. The effective permissions, we calculate that, and basically those are going to be permissions that are going to be inherited by this user. So maybe he belongs to a group that he has inherited permissions. So now we see a different story. Instead of having 200 and something permissions, now we go into 538 different permissions, right? So we got a lot more permissions here that maybe are granted from the inheritance group that that user belongs to. So that is another thing that we can get here in the user permissions. Now we can take a look at the role permissions and also object permissions. So if I go here to a specific user or views or anything else, any other object that I have, I can take a look at the permissions. Oops, sorry about that. But the permissions that I have that specific for that specific object. Okay. Again, to summarize this, it's going to be a product that looks at your, it does a scanning of your SQL Server. It looks at your security model, and it brings and reports on all of that information. The last thing also that we have here is the reports. So you can do a lot of these reports that are already canned reports that come with the tool that basically you can run those reports and see that information. So if you want to see, for example, a report on server roles or the risk assessments that you have, or maybe the user permissions that you have in a specific server, in a specific database, then you can run that report from here and it will give you that type of information, okay? So let's take a look at the other product that is related to this one, which is called the Compliance Manager. And as Brian was talking about, some things maybe are no longer, we don't say that, you're supposed to enable or disable this anymore because it doesn't matter, like he was talking about the XP command shell. So maybe some of those things we want to do it, we want to catch those at an audit, right? And this product basically allows you to do that. So all the activity that is going into a SQL Server, then we are able to audit that. Now, you probably have seen different audited products for SQL Server, and they do it from a different approach that we do. They usually grab everything, right? And they create a log of all the audit information. And then from that, they filter all of that information. Well, we think that that way of doing it, it's a waste because you're auditing a lot of different things that you don't need to audit. You're creating a huge file that then you have to save somewhere, and then you have to filter that information, which it might be very, very taxing on those resources, right? The way we do it is we audit what we need to audit only. So we audit only of the things that we want to audit. So we grab that information, which is going to be a lot less. Then we can filter that down even further if we want to. But we only are gathering that information that we need, right? So that is the whole thing, the whole philosophy of the product, the way we do it. Now, you can see here that I have an instance, and at the instance level, I can see some of the things that have been going on for the last 7 days, the last 30 days, whatever it is, right? I can see all of that information here very quickly. So for the last 30 days, I got something here at the end of the October, right? And you can see some bands here. So basically in this area, fail logins, I had more than a limit that I gave it, basically a threshold. So it says that if I have more than 500 logins per hour or 2,000 logins per hour, that's going to be either warning or critical. I can do that per day or per hour, depending on how I want to do it. But that's going to give me an indication of what's going on my servers in the last 7 days and last day and so on. And then I can see all of the events here. So again, we can capture here DMLs, insert, update, deletes, executes, DDLs, which are a ton of them, like DBCC read, and all of these that we have here, alter trace, alter store procedure, all of those we're going to capture here, right? Logging events, fail login, logouts, logins, right? And security stuff, right? Administrative actions like backups and restores. All of that information, again, we can capture here, but you can tell exactly what you want to capture, right? So for example, here I go into my the database level, and I said the only things I want to capture at the database level for me is going to be these two things, right? It's going to be fail logins, administrative actions, and DDLs. I don't want to do logins, logouts, or security changes. It's up to you how you want to do it. Now, are you in a compliance? So you need to be in compliance with something else, with the regulation? Well, okay, we can do that too. We can start with a template that would enable or disable based on that security, right? So is it CIS? Is it DISA? Right? Is it HIPAA? Is it PCI? Right? So if I do that, then it tells me that I need to have login, logouts. Fail logins, I already have it, so that's why it's grayed out. So it's going to tell me what I need to have for that specific regulation. Okay. Now, I can do the same thing per database. And now the beauty about the database is I can go here to the activities as well, right? And I can say I want administrative actions, DDLs, and DMLs. But I don't want any selects. Why? Because selects are too many. It's not doing anything. It's not doing an insert. It's not doing a delete. It's not doing an update. But somebody might be reading some information. Sorry about that. Some information about the what they're reading, right, from that table. So if they're reading some information that it might be sensitive, I want to capture that, but I don't want to capture all the selects. For that, we can do it in this tab right here, which is called sensitive columns. We're going to see it in a second. But before I go into that, I want to mention something here, because we can say here exactly what we want to collect. First of all, Taylor here is a instance that I have more than 20 databases, but I'm only auditing 2 of those. So the other 18, I don't care. Okay. Here, the DML selects, I don't care about, I can do all the objects, I can do all the user tables, but I'm only doing here 3 tables of all the 10 or 12 that I have. I don't care about these other ones, whether I do a DML or not. I only care about those 3, which are the important ones that I need to do auditing. Okay, so this is a beautiful thing to do, because you're not collecting any extra information that you don't need, and thus you're going to have less storage requirements and an easier and manageable database to filter that information. The other thing that we do is we can capture the before and after. The before and after is basically if you make a change. In this case, if I make a change only in the columns of first name, last name, or salary. So all these other ones, I'm going to capture the DML. So if I change the employee ID or the hire date, I'm going to know that we made a change, a DML, an insert, an update. Okay, but I'm not going to give you the field value, the before and after. So what that means that in this case, if I change the first name from Joseph to Joe, right, it's going to tell me that it was Joseph before and now it's Joe. Or the salary from 25,000 to 27,000 is going to give me 25 and 27,000, right? So it's going to give me those for those specific columns that I want. And then the sensitive columns is going to show me that information only if I have on this column commission rate. That is a sensitive number that I don't want all of my partners to see. If anybody sees that information that is sensitive, I want to know who did it. But if I show only the partner name, right, or the sales that they're doing, the low sales, high sales, that is not sensitive. What is sensitive is the commission rate. So I don't want to capture selects that do information that is not sensitive, but only if somebody reads that sensitive information. Okay, so that's the way basically it works here. And then you can do a lot of different reports on this information. You can do a lot of filters. So if you want to filter the data and I only want to see login data, I can see login data. If I want to see DDL data, and I can see all the detail of that, right? When it happened, what was the user, the category, DDL, the type is an alter schema from where, in this case from the command line, the target, the object, DBO, and then it gives you the full SQL statement that we capture. So when it happens, from where, what application, all of the detail information. Okay. If you want to take a look at DMLs, all the updates that have occurred, right? And if you want to see a DML, let me see if I have one here very quickly that I can show you, or maybe not. But if I have a DML, I can see also the updates, for example, if something occurred, maybe that's today only. Let me see the last 30 days if I see some of those. Yeah, here we go, might be here. I want to show the before and after how it looks, but I might not have any of those here. I was trying to look at it and I can see it very quickly if I had it here, but I don't have those. But basically, it will give you that information of the before and after. So what changed before and after on that, okay? Now, that is a summary of basically what the product does. Again, it's a product that it will do the auditing. We do it from a different perspective. We collect the information that is needed, and then we can filter it down more depending on what you need from that data, and it's going to get all the activity, but you decide what is it that you want to collect. It's going to be all the activity for login, it's going to be the activity for DDLs, it's going to be the activity for DMLs, insert, update, deletes, executes, and then it's going to have information about security also and administrative actions that you're going to have here. So those two products should cover a lot of the things that Brian was talking about to enforce your security and to make sure on a day-to-day basis you can audit check those things as well. Okay, and with that, I think that is my time. It's 11 o'clock. I want to see if there are any questions. So Carmen, can you take it and see if there's any questions?
I'm looking at the question panel. I don't see any questions. I would like to invite any attendees, if you have any questions, to write one now. Or, you have Brian and Ray's emails. You can shoot them an email and they'll certainly get back to you as soon as they can. Yeah, so with that, I think that pretty much wraps everything up. So thank you everyone for attending.
Thank you so much.
Great, thank you.
Bye-bye.
All right, have a great day. Bye.